Hello, my fellow classmates. I hope you're having a wonderful day.
Okay, guys, we are going to review factoring. So, when we start factoring, the first thing that we need to look at or look for is GCF, so greatest common factor. From there, you have a few different options. You have the x, you have the super x, or you have difference of squares. Okay? Those are the four ways that we're going to factor. Always start with GCF and then use the other three as needed. Remember, for the x and super x, it has to be 3 terms with your highest exponent being a 2. With difference of squares, it's 2 terms, a subtraction sign in between those 2 terms, and both terms are perfect squares. Okay, so I'm going to go over a few examples that helps us review all of these before you work on your factoring review assignment. So let's look at 2a squared, and you don't need to write any of this down. I just want you to watch and pay attention. So 2a squared minus 9a. Okay. Step 1 always should be GCF. So is there a greatest common factor between 2a squared and negative 9a? I hope you're saying yes, and that factor is an a, leaving me with 2a minus 9. Now, if I look at what's in parentheses, there's 2 terms, there's a subtraction sign, but these are not perfect squares. Okay, so we can't do difference of squares. There's not 3 terms, so we can't use the x or the super x, which means all we were doing for this problem is GCF, and we're going to leave our answer just like that. Let's look at 2k squared minus 5k minus 3. So again, GCF should be your go-to. Can we do with GCF? There is not a GCF between those 3 terms. So we look at what our other options are. Okay, so x or super x. We can't use difference of squares because there's more than 2 terms. So x or super x. We're going to use the super x because the number in front of k squared, or my leading coefficient, is greater than 1. Okay, so the super x says a times c on top, so 2 times negative 3 is negative 6. B on bottom, which is negative 5. And then my a term with my variable. What 2 numbers multiply to 6 and add to negative 5? Multiply to negative 6 and add to negative 5. So if I did 3 and 2, right, because 3 times 2 is 6, one of them needs to be negative to give me a negative 6, but then there's no way to make that a negative 5. So my only option then would be 6 and 1. 6 times 1 is negative 6, and the negative 6, it needs to be a negative 6 because negative 6 plus 1 is 5. Remember to reduce. So 2 goes into itself once, 2 goes into 6 3 times. This side cannot be reduced, so final answer is k minus 3 times 2k plus 1. So really look for what multiplies. Make sure you check your work, okay? So you're checking that these factors multiply and add, because sometimes you'll find factors that multiply but that don't add properly. So just be very cautious of that. Let's look at x to the third minus x. So again, we start with greatest common factor. So what is the greatest common factor between x to the third and x? Hopefully you said x. So if I pull out an x, I'm left with x squared minus 1. Remember, if you take everything out, there is still a 1 there. Okay? Now I'm looking at what's inside the parentheses. Can I do anything else with this? Well, I notice there's only 2 terms, and the only option then at that point is difference of squares, so it doesn't meet all the qualifications. Are there 2 terms? Yes. Is there a subtraction sign between them? Yes. And are both terms perfect squares? Yes. Okay, so I have my x on the outside. The square root of x squared is x. The square root of 1 is 1. 1's plus, 1's minus. Number 4, 36p squared minus 184p minus 192. All right, we are looking for a GCF. I can guarantee there's probably one in there. think about factors of 36. So you have 36, you should check to see if that works. You have 12, you have 9. But in this case, my GCF is going to be 4. That is the largest number that I can pull out. So when I pull a 4 out, I'm left with 9p squared. 184 divided by 4 gives me a negative 46p. And 192 divided by 4 gives me a negative 48. Check one more time just to make sure there's nothing else that goes into 9, 46, and 48. Just in case you didn't pull out the largest GCF originally. But there isn't, so I'm going to go to my Super X. 9 times negative 48 gives me a negative 432. And then I have a negative 46 on the bottom. A 9p and a 9p. So two numbers that multiply to negative 342 and add to 46. I have no idea what the factors of 432 are, so I'm going to start dividing. If I divide by 2, that doesn't do me any good. 3, no. 4 is getting closer. 5 I know is not going to work. 6 is even closer. 7 doesn't work. 8. So 54 and 8, if I add them together, subtract them, they'll give me negative 46. So I need this 54 to be negative. I can reduce. 9 goes into itself once and goes into 54 6 times, and then that part doesn't reduce. Don't forget your GCF at the top, and then I have p minus 6 and 9p plus 8. And then lastly, we have n to the third minus 18n squared plus 80n. GCF between all three, okay, you should recognize right away that that's cubed. So I can definitely pull out an n. There's no number I can pull out. So I'm left with n squared minus 18n plus 80. Here I can just go straight to the x if I want to because the leading coefficient's 1. Or if you like the super x and we know that it works for everything, I can do super x. So 1 times 80 is 80. Negative 18 on the bottom with an n and an n. So two numbers that multiply to 80 and add to negative 18 are negative 8 and negative 10. Yep. Can't simplify anything. I have n on the outside. You can't see that, so let me fix it. There we go. N on the outside, n minus 8, and n minus 10 as your final answer. Just make sure that you are checking all 4 ways to factor. Always, 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 always start with GCF. Sometimes you can factor out a GCF, sometimes you can't. The x and the super x have to have 3 terms. Highest term is an x squared or whatever your variable is squared. And then difference of squares, you have the 3 criteria. So 2 terms, a subtraction sign, perfect squares. Okay? If you can identify how to factor each of these, you are going to do just fine, not only on today's assignment, but on the test that is a week from today.